Have you ever wondered what happens when light reaches an object? Or how we see so many different colors? Let's find out. First, what is a reflection? A reflection is when light bounces off an object. If the surface is smooth and shiny like glass or a mirror, it will reflect at the same angle as it hit the surface. Scientific principle number 9. Reflection occurs when light bounces off an object only in a certain direction. This occurs when the surface is smooth or polished. Scientific principle number 10. A reflection of one object is seen in a second object only if the second object reflects light, not if it scatters it. So what is scattering? Scattering occurs when light bounces off a rough surface. Light rays hit the surface and bounce off in all directions with no set pattern. Scientific principle number 8. Scattering occurs when light bounces off an object in all directions. This occurs when the surface is rough or unpolished. So what is light transmission? Light transmission occurs when light rays go through an object such as a window or something clear. Scientific principle number 11. Some objects are transparent and let light pass through them in an orderly fashion. And the last one, what is absorbing? Absorbing occurs when light is taken in by an object, causing something to happen, such as heating up or being converted into energy. Scientific principle number 13. Light can make things happen when it is absorbed. What are the 3, but really 4 ways light can interact with objects? Number 1, reflecting. Number 2, scattering. Number 3, transmitting. And number 4, absorbing. What happens when light bounces off a mirror? When light bounces off a mirror, most of the light will be reflected back at the same angle that it hit the mirror, while a little light will be scattered and absorbed. What happens when light bounces off a piece of paper? Most of the light will be scattered in all directions, while a little light will be absorbed and transmitted. So why does polishing objects make them smooth and shiny? When polishing an object, the polish will fill in the cracks and smooth out all the bumps, making the object more reflective. So how does a mirror work? Well, since a mirror is smooth, it will reflect most of the light hitting it, and you will see an image that is the same as the object in front of the mirror. What happens if the mirror is scratched? If a mirror is scratched, more of the light will be scattered rather than being reflected. What are optical fibers, and what are they used for? Optical fibers are a special wire that has a glass core within it. They can be used for making fun lamps, sending TV signals, aiding in medical operations, and sending information across devices through the internet. So how do optical fibers work? Light is constantly being reflected within a glass core from one end to the other. Explain the difference between transparent, translucent, and opaque objects and give an example for each. Transparent. Objects that let most, if not all, light pass through. An example of this is glass. Translucent. Objects that only let a little light pass through them, like frosted glass. Opaque. Objects that do not allow light to pass through them. An example is this brick wall. So what happens when light hits an object? When light hits an object, it will reflect, scatter, transmit, or absorb, or really any combination of any of these 4. Scientific principle number 12. When light reaches an object, it is scattered or reflected, transmitted, absorbed, or some combination of these. So what happens when light hits a clear window? Well, most of the light will transmit through the window. Some of it will scatter, and a little bit will be absorbed. So what is a steam turbine, and how does it work? A steam turbine is a massive machine with giant fan blades inside. When the fan blades turn, it uses the turning motion to generate electricity. How is most of the electricity generated in the United States? Most of our electricity is generated by coal power plants, which burn coal to heat water until it becomes steam to be used by the turbine. So what is something that causes all of these? Heats things up, makes plants grow, and produces electricity. It's the absorption of light. When light gets absorbed into an object, amazing things happen. Scientific principle number 13 says, light can make things happen when it is absorbed. So what objects would you expect to absorb the most light? Objects that are dark in color would absorb the most light. What objects would absorb the least light? Well, objects that are light in color will absorb the least light. So what is solar energy? Solar energy is created by the sun. It can be used to power electric devices and homes, water heaters, and it can move things. It can even make living things grow. Since it's plentiful, it does not create pollution, and it's considered an excellent energy source. So what if we combine 100% red light with 100% green light? We would get yellow. What about 50% red light and 50% blue light? You'd expect to get purple. And 100% red light with 100% blue light? That would be pink. What would you expect if you put 100% green and 100% blue? You would get turquoise. If you mixed 100% red, 100% green, and 100% blue, you would end up with white. If you mixed 0% red, 0% green, and 0% blue, you would end up with black. And you might have guessed it, if you mixed 50% red, 50% green, and 50% blue, you would end up with gray. Scientific principle 14 says, when different colored lights are mixed, they appear as a new color, brighter than the original colors. So what does the retina do? After detecting the light in the eye, the retina will generate a signal to be sent to the brain. The two cells that are found in the retina are cones and rods. So what's the difference between a cone and a rod? Cones are sensitive to different colors. The cones specifically are sensitive to red, green, and blue light, while the rods are only activated in low light, making things look like shades of gray. What happens to white light to make objects appear as different colors? Objects reflect or scatter a certain color while absorbing all the other colors. Our eyes respond to the mixtures of red, green, and blue light. So what is diffraction? The process of bending light around an obstacle. The light will spread out after it moves through a small place. So what colors make up white light? The way to remember this is Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet make Roy G. Biv. Scientific principle number 15. White light is a mixture of all colors of light. It is the brightest color. Black is associated with the absence of color. So how does light travel through a raindrop to give us a rainbow? The light enters the raindrop and is then bent and reflected back out the same way it entered. The reflection of that light leaves the raindrop and each color moves in a predictable direction. The refraction and reflection of light by the raindrops causes the colors to spread out and create a semicircle of colors in the sky. So how much light would you expect to be transmitted, absorbed, and scattered on a whiteboard? On a whiteboard, we would expect most of the light to be scattered and a little bit of the light to be absorbed. How much light would be transmitted, absorbed, and scattered on a black tabletop? On a black tabletop, we would expect most of the light to be absorbed and a small amount to be scattered. So under what conditions would you expect a red object to appear black? Well, here are some red objects. If we take a blue filter, only allows blue light to travel through it, the red objects will appear black because the red objects only scatter red light and absorb all other colors, and the blue filter only allows blue light to come through, so the red objects will appear black. Scientific principle number 16. Colored objects scatter only certain colors of light and absorb the rest. So when white light shines on an apple, the apple appears red. Why does this happen? An apple appears red because when the white light hits the apple, it will scatter only red light while absorbing all the other colors that make up white light. So that's what happens when light reaches an object, and that's how we see all the colors that we see.